Uh, good day students. Now we are going to see an important chapter in the NEET physics session, which is atoms. You know very well about atoms. Atoms is the one that constitute the most of the constitution of the electrons, nucleus and electrons. Okay, so the nucleus of the electron, how the electron is, how the position of the electron, whether it's circular orbital motion or in elliptical motion or in which type of the motion it is assessed. So what is the speed of the electrons, how the electrons are rotating around the nucleus. So this is the important contribution that only we going to see in this chapter. So we are going to see in all the details how the position, motion, how it's affected, what is the revolution, it's revolution of the electrons around the nucleus. Everything we are going to see in details in this chapter. Now atoms. So the atoms there. So the moment atoms you know, right? Electron will rotate around the nucleus. So the electron will rotate around the nucleus, that forms the stable atom. For example, if it is not rotating around the nucleus, what will happen now? It will relate to what it will happen? It will lead to, if electron that has to revolve around the nucleus, that will lead to the stable atom. If it is not revolving around what will happen to the atom? Unstable. So it cannot stay for a long time. Anything you can take. Anything you can take. Okay. So anything you can take. That's why I am taking any. Okay. Name any radioactivity element. Yeah, anything you can take. More probably we will use here was more probably they will use polonium, not for uranium. Uranium is a radioactivity. More probably they will use polonium. I am taking here polonium. Okay, I am keeping it. Okay, what will happen? The moment I keep it, immediately you know the polonium will give rise to three types of particle. What is that? Alpha, beta, gamma. Okay, you know everything. Okay, the moment I am taking water, okay, water I am keeping here, will it give rise to alpha, beta, gamma? Nothing. Water will stay as itself. Water will stay there for itself. Okay, but if I take radioactive element, that will give rise to alpha, beta, gamma, and alpha is positive charge, beta is negative charge, gamma is neutral. So neutral means zero, no charge, it has no charge. This already we discussed, I think, many classes. Repeatedly we are discussing it. Okay, right? Okay, so what is a so now we go for this one. Okay, so what is this? Helium. Helium is alpha. This one is gamma. Gamma has no charge. Yeah. Then beta, which is electrons, almost like electron, which is negative charge. Okay, so now it comes that if I take water and keep, will it give the radioactivity? No. So why the uranium radioactive element will give rise to three elements, three particle like this? So what is the motivation? Because it's instability. Whatever you do, this particle if you take, if it's unstable, it will give rise to a stable particle. But this particle alpha, beta, gamma, all are stable one. So from this no particle will evolve. That means this instability will give rise to stable particle. Okay. In last class also we discussed lot of things in uranium and nuclear fusion, nuclear fission, everything we discussed last Saturday that in that class. Okay, so this is so if this is the state, that means what is the stability of the particle? Any particle if you take, it has to be stable. If it is stable has no problem. If it's unstable, it give rise to stable molecule. So if the stable molecule is there, so what makes the main contribution? The main contribution comes from this nucleus and electron. So the nucleus and electron that denotes the that decides the main criteria for the stability of the molecule. So in this scenario, now comes the Rutherford. What Rutherford? You know, right? Rutherford.
Yes, sir. Gold foil experiment panna.
If perform the gold foil experiment and confirm the size of the nucleus. So size of the nucleus, yeah, he performed all the variety of the experiments. Okay. So in this scenario, he only confirmed that electrons are revolving around the nucleus. So what he took? He took the radioactive element like polonium and keep it in the material and surrounded by the gold foil. What is shown is showed here the three particle alpha, beta, gamma evolved, and it's scattered around the various angles. Okay, so it's scattered on various angles, and he found out that some particle evolved from the stable particle evolved from the unstable particle. That means I want to get the stable particle, means I have to get mostly from the unstable particle. So this scenario I already explained you. It has one more application. Do you still remember? It has one more application. This has one more application. What is this? This one? Gamma rays. Gamma rays. Okay. Gamma rays. It has a special application. Okay. For example, I want only gamma rays. Okay. But what is the material I am getting from it? Polonium. But I don't want alpha and beta. It has certain application that's different, but in certain application where the gamma rays is applicable. Where the gamma rays will be applicable? I explained to you, I think, in the last class.
Electromagnetic radiation.
Where it is applicable. Gamma rays is electromagnetic radiation. Okay, I am taking polonium, and from that I am getting the gamma rays. In addition, you will get a alpha and beta. I don't want that alpha and beta. Okay, so I can suppress it. Okay, I can suppress it, and I can get only only gamma rays. Okay, so in which application where it is applicable? Gamma rays. I already explained you, I think. No? You don't know. Scan. You understood scan. What is the purpose of scan? Any purpose scan. Why are they taking for scan? Especially scan, not X-ray. X-ray is different. Okay, scan. Especially when you have when the person who is met with the accident get the especially traumatic brain injury. Traumatic brain injury. This is what is this? This is a type of special brain injury that will affect the brain during the accident. When this accident is there, how depth how depth the injury has happened. Whether it's the brain, if you take certain brain, you take the depth, total depth. Okay, this is the total depth. Okay, this is total depth. How the depth? Where is the depth? Where is the exact position? Is it in the you know, right? Three types of brain: cerebellum, cerebrum. Middle, yeah, no, yeah, medulla oblongata, cerebellum, then no, one more thing is there, no? Only, huh? So three part of the things, cerebrum. So total brain they will keep divided and keep. Any accident happened, any injuries happened means it should be fall into these three regions. So to point out exactly where it is actually happened, so you need to identify it. So for that only specifically they use the gamma. That's a scan. So this is the purpose of scan. Okay, the purpose of scan is that. So this is the purpose of the. From that they will get this is the this is beginning the stability and instability of the compound. Anything you can take, any compound you can take. As far as the gamma rays. What is the now it comes? What is the gamma rays now? What is gamma rays now? First you have to see what is application. What is gamma rays? No, neutrally charged. It's one of the electromagnetic spectrum. What is its wavelength compared to radio wavelength? Why is they specially use gamma rays? Instead of they can use radio waves, no? Wavelength with respect to wavelength. See how many spectrum you have? See, everything is continuity, right? 7 spectrum. What is the first one?
Gamma rays.
No, any one person.
Gamma rays.
First one is gamma. Right. Second is?
X-rays.
Third is?
UV.
Fourth is?
Visible.
Fifth is?
IR.
Sixth is?
Microwaves. Radio waves.
Radio waves. That's so totally wave. So in this specific scan, they can use radio wave, right? Why they specially using gamma rays? Higher wavelength. So the wave is depend upon the wavelength that is applicable. So where the wavelength is there, they depend upon the wavelength. Depend upon the wavelength, they use for the application. So another process. That's why in the X-ray, that's why they in the when you get met with accident, you get a fracture. They use specifically after gamma rays. Next is X-rays. Okay. So this is a various applicability. So now comes the now comes this is the nucleus and this is the electron. Now, so this now if we found out that the electrons are revolving around the nucleus. Okay, the electrons revolving around the nucleus. Now two types of force will first the two types of force will come into effect. What is it? You know, right? Wait. Who wants to tell two types of force and why it is? You want to tell or I have to tell? We will see whether you are telling. First,
electrostatic force of attraction.
Wait. Who wants to tell? Who wants to tell two types of force? Who wants to tell? Who wants to tell two types of force? You know, right? Electrons are revolving around the nucleus. The moment electrons are around nucleus, it's to stable one. If it is stable one means what is the first force? Yeah, that's only I am asking. Who wants to tell? No, you don't know or you don't know to tell. Who wants to tell? No, just now you told me something. No. Okay, I have to give to others. Yeah, you want to tell? What? Okay, yeah. Yeah, no, not repulsive force. How it will be repulsive force? Force of attraction. Force of attraction. Okay? Force of attraction. That is, electrons is attract towards the nucleus. Okay? The electrons are attracted towards the nucleus. So the force of attraction. The force of attraction, how we can, force is directly proportional to m1, m2 divided by r square. R is the distance. m1 and m2 is the mass of the first substance, mass of the second one. Here mass of the first is the nucleus, mass of second one is electron. And its counteraction is, its counter force is, force of attraction means immediately there is counter force is centripetal force, which is centripetal force is mv square by r. So what is m? M is the mass, v is the velocity and r is the radius. So now now this one is a centripetal force versus force of attraction. Force of attraction is given by 1 by 4 pi epsilon 0. This you know, right?
Okay.
This I think epsilon 1 by 4 pi epsilon naught E square by R square. What is E square here? E square. What is E square here? Just now I explained you.
Electrostatic force of attraction.
What is E square here? What is force of attraction? Force of attraction. What is force of attraction? F is directly proportional to m1 m2 divided by r square, and G F is directly proportional to 1 by m1 m2 divided by r square. What is m1? M1 is a mass, m2 is the mass of second one, r square is the distance between the two masses. Okay, that's a force of attraction. Now F is equal to G or constant, some constant k you can keep, k into m1 m2 divided by r square. And what is k value? 1 by 4 pi epsilon 0. This is everything is constant value. Everything is constant value, they will give it. Okay, so F is equal to 1 by 4 pi epsilon 0 E square divided by r square. What is r here? What is, okay, first one. No, first one you take 1 by 4 pi epsilon 0. What is 1 by 4 pi epsilon 0? At least you tell this. Constant. Then for r square. What is r square here? Distance between two masses. Then E square is? E square is a mass. E square is a mass of, what is mass here then?
Mass of electron.
When I ask you a question, you will throw it. All the probability you will throw, so I have to pick which one is the correct one. That's all. This is the same trend is following. Mass of the electron and mass of the nucleus. I told what I explained in law of motion, they are applying here. This both everything is applying the law of motion. I did that revision part, no, law of motion. Okay, what I told you in the law of motion? Law of motion. What I told you? For example, I am taking mass and sun and earth. Okay, what is the force of attraction? You forget about this. Okay, you forget about this. We go for sun and the earth. Okay, there are how many planets? Okay, you assume 10 planets. Don't assume that 8 planets or 9 planets. You just skip it and assume 10 planets. Force. What is how the earth is stable? Earth is stable. I explained you, I think, in law of motion everything. The earth is stable due to force of attraction between sun and mass, sun and earth. If it is there is a force of attraction Fc. So Fc is a force of attraction. F is directly proportional to m1 m2 divided by r square. M is the mass of sun, m2 is the mass of earth. R square is the distance between sun and earth. If the force of attraction is not there, what will happen to earth? Earth will leave the orbit. Earth will leave the orbit. Earth will leave its orbit. Will travel away from its orbit. So it will go away from the sun. Okay. So it's stable due to force of attraction. This also I told you, I think. Two possibilities there. For example, a stable ion inside Earth is core. The core region has the huge amount of iron. Now I am taking out all the ions now. What will happen now? Yeah, force of attraction will leave. Earth, the force of attraction will decreases. Earth will leave the orbit. You forget about this one. Okay, we'll go for that one. Okay, there what will happen? This I already, which class I explained you? In gravitation. I didn't teach full class, but revision part I teached it. Okay, the same concept only here. So the same concept here. Now let us assume that there is a ion there, the force of attraction. Okay, force of attraction. Now I am digging the earth. I am taking out all the ion particle. Okay, all the ion particle I am taking out. Okay, so what will happen now? What is the content of the, now what will என்னாச்சு? No. Now I am taking the, I am digging, and taking all the iron particle. What will happen to now? Earth will leave the all the orbit, because the force of attraction, there is no force of attraction. Earth becomes some of the some like asteroid, some of the object, it becomes like object, so everything vanished. That's why you leave the orbit. Now the same force is coming here, summing the force of attraction. The force of attraction is 1 by 4 pi epsilon 0 E square by R square. Okay, so in the similar trend equal to mv square by R. What is m? Mass of what? What is the mass? Mass of centripetal force, which is rotating around which? Electron is revolving around the nucleus. Okay, what is mv square by R? mv square is the, it's not attractive force, centripetal force. This is only force of attraction. So the Fe given as force of attraction, which is this one, and this one is Fc, which is centripetal force. Okay. Now now you have to tell centripetal force. What is mv square? Mv square by R. Who is telling? Any one person. Any one person who is telling? Huh? Okay, you want to tell? mv square by R. No, who wants to tell? I don't have time. Okay, I will explain. No, who wants to tell? What is mv square by R? You have to just explain what is mv square R. Why it is so, that's all. Why everybody is blinking? That means you didn't understand. Okay? This at least you did understand this force of attraction. That is okay. This is constant. Okay. Now we have to explain why it is mv square. This because I explained you in law of motion. This also I explained in the law of motion. Newton's law of motion. Newton's law of motion. So who is explaining? Huh? I explained you the law of motion. At least I devised it. That's all. Who wants to explain? What is this mv square? Okay, mv square is mv square by R, mass of the electron, which is active force, the centripetal force that acting on the electron that is revolving around this nucleus, and v is the velocity. What is the velocity? Velocity of the, what is v? V is the velocity. What is of v? Velocity of the electron. The which speed the electron is rotating. How the position will be? This is the nucleus. This is the electron. Okay. What is the? So this is the electron. Okay. How the electron is rotating around the nucleus. Okay. So mv square by R, mass of the electron, velocity of the electron. R. What is R? At least R. You tell me. What is R? Distance of? Huh? Distance between the nucleus and distance between the nucleus and electron. Nucleus and electron. That's all. This is a centripetal. So both are equal. Both are equal. So that's so both are equal. So when it's equalized, what will happen now? R. This value R. So if I take this value, if I bring this R square upward, what will happen? This R and this R will cancel. So you'll get R. So this will go to the downward. So it will be E square divided by 4 pi epsilon 0 mv square. This one is E square. No, it's not a big issue. Here they are taking as, instead of mass, they are taking as E square. Yeah, just you can take anything as A also you can take, B also you can take, Z also you can take. Nothing is harmful. Just for tally the equation they are taking it. It's not a big issue. Okay. For mass means you should not take all the time M. You can take anything as you want. Okay. Here they are taking as E square. Okay. So this is not a big issue. So now R is equal to E square 1 by 4 epsilon 0. This mv square will go down. Now what is next? Kinetic energy. Ke. K is equal to half mv square. Okay. Of mv square. Then how, at least you tell this, how you got this. At least anybody one who you tell how you got this. K is equal to Ke, not K. K, not K. K if I put, it will be like constant. So it should be Ke and it should be Ue. Okay. Then this one is Te. Ke, Ue. Yeah. So now you have to tell Ke is equal to half mv square. So equal to E square by E square divided by 8 pi epsilon 0 R. How you got this? Huh? 4 into 2, 8, that I know. Everybody knows that 4 into 2, 8. I don't want this constant value, 8 pi epsilon 0, e square by r. That's all. You forget about this value, okay? This one is a constant value. Everybody knows that, all the constant value. No, you need not worry about this. You need not worry about this, in fact. Everybody knows a 4 into 2, 8, everybody knows that. How you got that? E square by r, at least. You understand now question, what is the question now? You understand the question. That means, see, kinetic energy is equal to half mv square, which is equal to e square by 8 pi epsilon 0 r. You forget about this 8 pi epsilon 0 is a constant value, you need not worry. So e square by r, how you got this value? Who wants to tell? You want to tell? How you got this? You understand the question now? Yeah, you tell. How you got? Correct. Or what do you take? Half mv square. You have to substitute this. What they do it, you take this v square here and r here. Okay. So now we got v square here. So half m, you substitute this value now. So the e square divided by 8 pi epsilon 0 m. So you understood now? No, you didn't understand. From the face itself I found out. See, r, this is the value, no? R is equal to e square divided by 4 pi epsilon 0 mv square. I can write it as e square divided by, no. V square is equal to e square divided by 4 pi epsilon 0 m r. At least you understand this, okay? So r is equal to e square divided by 4 pi epsilon 0 mv square. V square is equal to e square divided by 4 pi epsilon 0 m r. Now I got a v square. What is k is equal to half m v square. So if I substitute this value v square here, what I will get? This value e square divided by 8 pi epsilon 0 r. Okay, do you understand this now? You understood or not? Yes. Okay, so this is also kinetic energy is equal to e square divided by 8 pi epsilon 0 r. It's no simple. R is equal to this value. Now v square I am taking upstairs and r I am taking down. Okay, so v square is equal to e square divided by 4 pi epsilon 0 m r. Okay, now I got v square. Okay, so k is equal to half mv square. So half m into, now again this v square value, okay. Okay, so e square divided by 4 pi epsilon 0 m r, half m e square divided by 4 pi epsilon 0 m r. Okay, so now now what you will get? By k is equal to e square divided by 4 pi epsilon 0 r. Now in the similar trend, now I am going for potential. This one is the potential energy. Potential energy is equal to e square divided by 4 pi epsilon 0 r. So now I am adding both. Total energy is equal to kinetic energy and potential energy. So where is the kinetic energy? Kinetic energy is equal to e square divided by 8 pi epsilon 0 r. This one e square divided by 8 pi epsilon 0 r. Here it is potential energy is equal to e square divided by 4 pi epsilon 0 r. So totally e square is equal to minus e 8. That's okay, fine. First one is that e is equal to 4 pi epsilon, this e square. So e square, no, I will come to the later, okay? No, potential energy is 0, negative here. Potential will be negative. Potential energy will be normally negative. Potential energy will be normally negative. See, since it's negative, Ke plus Ue is equal to, this one is positive value, this one is negative value. So when I add it, this totally will be negative value. Okay? So first did you get this now? E square divided by 8 pi epsilon 0 r. Here e square is divided by 4 pi epsilon 0 r. Okay, so total energy is equal to e square divided by 8 pi epsilon 0 r. Okay, now it comes that potential energy is negative. Why the potential energy is negative? Normally all the potential energy will be negative only because normally all potential energy will be negative due to, because the potential energy that is stored, what is the potential energy? Potential energy is the potential energy at the potential energy that is attained at the rest. Okay, when the potential energy is when the particle is falling out, what will happen now? The potential energy, the kinetic energy will increases, potential energy will decreases. So this decrease in value, this what are the potential stored only will be converted into kinetic energy. So this you know right now. So that's why we are adding it now. K is equal to Ke plus Ce is equal to E square divided by 4 pi epsilon 0 R minus E square divided by 4 pi epsilon 0 R. So how you get 1 by 8? That you know, right? LCM, yeah, 1 by 8 minus 1 by 4. So you have to take that LCM, etc., etc. Okay, so finally, now we comes the why potential energy is negative. Potential energy is a 1. That potential energy is the 1. That is this you know, right? Potential energy 1, that is storage. Okay, it's almost at the rest. Oh, so what are the energy that is stored? That will be at the rest. Okay, so this potential energy will only decrease. This you know, right? I told you the two masses M1 M2. But the potential this you know, right? I already explained you this also. That potential when the kinetic energy, when potential energy decreases, kinetic energy increases. So here the kinetic energy is the kinetic energy will be always positive. The potential energy always at the energy that they caught at the rest. So that's why it's negative. Okay, so you have to add both the thing, Ke plus Ce. So you are taking this?
Yes, sir.
You are taking this? Okay, now we go for atomic spectra. What is the atomic spectra? Atomic spectra is the one by which the atomic spectra is the one by which you will get the various spectrum of series. When you will get the various spectrum of series, when the spectrum of series forms from the lower level to the higher level to the lower level. That means when any spectrum lost its energy, what any electron that is falling from the higher to the lower level, what will happen now? The electron that is falling from higher level to the lower level, it will lose some of the energy. Okay, when the electron will fall from higher level to lower level, it lose some of energy. So that energy will be give the spectrum. So that is the atomic spectrum. So that is the atomic spectrum. So any spectrum if you take, I am getting one small spectrum. Okay, just you can take and tell, you can take one small spectrum. Any spectrum you can take one example. Okay, I am seeing it. I am getting certain energy. So where this energy comes from now? Any spectrum you can take. I am having this spectrum. So how this spectrum getting? I got this now. From where? From electrons. From the electrons loss of energy, the electron will move from how many orbital? What is the orbital position of the various atoms? Anyone you can take. For example, how many? So the outermost the electrons that is rotating of the outermost thing is outer orbital. And this one is the electron which is moving towards almost like towards the nucleus is inner orbital. So if the electron will flow from if the electron flows from the outer region to the inner region, you will get the you will get this loss of energy. That loss of energy will be obtained in the spectrum. So in the form of spectrum. Okay. So the various spectrum. So the various spectrum is Lyman, Bastion, bracket, and Puffin. So how many? Yeah, first one. What is the first one? First, no, first one. Balmer. Balmer. 25 you have to bring. So totally how many spectrum we get now? So totally how many spectrum is there? 5. So which is Lyman, Bastion, bracket, Puffin. No, one is missing. No. Balmer. Yeah. First. Lyman, Bastion, and Puffin. So for Lyman, Balmer, Bastion, bracket, Puffin. So 1, 2, 3, 4, 5. So for a Lyman means lowest level is 1, so highest level is 2, 3, 4. Bastion is the lowest level is, or Balmer lowest level is 2, highest level is 3, 4, 5. No, 4, 5, etc. Etc. 2, no, it's not 2, 3, 4. 2, 3, 4, etc. Okay, and this one is 3, 4, 5, etc. This one is Bastion is R into 1 by 3 square minus 1 by n square. N is equal to 4, 5, 6, etc. So bracket is 1 by lambda R 1 by 4 square minus 1 by n square. N is equal to 5, 6, 7, etc. Like this, perfect. So these are the various spectrum. So for example, I am taking just on Lyman. First one I am taking. So second one is 2. So if I substitute 1 by 1 square. So 1 by 1 square is 1. So here minus 1 by n square. N square maximum value I substitute is 2. So if I substitute, what happened? So 1 minus 1 by 4. 4. 1 minus 1 by 4, which is 1 minus 1 by 4 is equal to 0.25. So 1 minus 0.25 is 0.75. So R into 0.75. Where R is the, what is the value of R? R is the Rutherford constant. Okay. So R is the Rutherford constant, which is 1.5 into 10 power 6. So 1.5 into 10 power 6. So 1.5 into 10 power 6 into 0.75. How much it will be? Approximately 1.5 into 10. 1.5 into 10 power 6 into 0.75. If the value is n is equal to 2. So what will be the value? Approximately 1.5 into 0.75. It will be approximately 1. It will be approximately 1.2. 1.2 into 10 power 6 meter inverse. So lambda is equal 1 by lambda is equal to 1 by lambda is equal to 1.2 into 10 power 6 meter inverse. So lambda you have to make, so 1 by lambda is equal to this value. So lambda is equal to inverse of it. 1.2 into 10 power inverse of lambda, 1 by lambda. You want to substitute? Okay. One by lambda is equal to r into 1 minus 1 square divided by 1 by 2 square. R is equal to 1.5 to 10 power 6. So this one will be around 0.5. So it should be 1.5 into 0.5, it should be 1.2 into 10 power 6 meter inverse 1 by lambda. So now lambda is equal to now inverse 1 divided by 1.2 into 10 power 6 into 10 power 6 meter. So 1.6. So what will be the value of this now? 1.1 divided by 1.2 into 10 power 6. What will be the value now? It could be approximately it could be 700 nanometer. Lambda is equal to now 700 nanometer. How? Because how it is 1 divided by 1.2 into 10 power 6. 10 power 6, if I go upstairs, what will it become now? Minus 6. So minus 6 divided by this one is 1 divided by 1.2. So if I divide by 1000 into 1000, I can put what will happen? 10 power minus 6 divided by 1000, it will become 10 power minus 9. So which is 10 power minus 9. This you have to do it, but I am telling orally. Okay, 10 power minus 9 meter. So 10 power minus 9 meter is nothing but it is denominator. 10 power minus meter, what it is? 10 power minus 15 meter, what it is? 10 power minus 12 meter, what it is? 10 power minus 6 meter, what it is? Yeah, tell me one by one. So you have to tell me now 10 power minus 6.
Micro, sir.
Who is telling? Any one person. 10 power minus 3, 10 power minus 6, 10 power minus 9, 10 power minus 12, 10 power minus 15. You don't know this, huh? Who is telling? Who is telling now? Who is telling? Who is telling? Who is telling now? 10 power? 10 power minus 3. 10 power minus 3, 10 power minus 6, 10 power minus 9, 10 power minus 12, 10 power minus 15. Huh? 10 power minus 3.
10 power minus 3 milli.
Milli, that's all. Why you put it? Simple thing here. 10 power minus 3 milli, then 10 power minus 6. Micro, then 10 power minus 9. Nano. 10 power minus 12.
Meter.
Picometer. 10 power minus 12 is picometer. Then 10 power minus 15. Not femto, Fermi. Not femto, Fermi. Fermi. So whatever the dimension you had come, they will give in this dimension only. Not, for example, 10 power minus 11 means you can't give as 10 power minus 11. Divided by 10 into 10 you have to add. So it will become 10 power minus 12 picometer. 10 power minus 12 meter, which is picometer. So here it is 10 power 6. 10 power 6. 10 power 6 I am going upstairs. It will go upstairs. Okay. Now it will become what? 10 power 6. 10 power 6 when it go upstairs, what it will become? 10 power minus 6. 10 power minus 6 I am into 1000 divided by 1000. So into 1000 means 10 power 3. Divided by 1000 means 10 power 3. 10 power 3, 10 power 3. 10 power minus 6, okay, into 3 divided by minus 10 power 3. Okay, I am adding into 3 10 power 3. Okay, so if I add this like this, what will happen now? 10 power now it become 10 power minus 9 into 10 power 3. So this, what is this one? X into this, what is this one? 10 power minus minus 6 This one is 10 power minus 6 10 power minus 6 into 10 power minus 3. What it is now become? 10 power minus 9. So it is
1 nanometer.
x into 10 power 3 into nanometer. X into 10 power 3 into whatever the value comes, you have to divide, you have to multiply with the 10 power 3 nanometer. Nanometer.
About 1000 nanometer.
Yeah, that's x value. X value. X value means whatever you can substitute whatever you value. I want to changing the denomination and nomination. 10 power, here it is 1 by divided by 1.2 into 10 power 6. 1 divided by 1.2, it will be roughly 0.9 I think. 0.7, something around 1 divided by 1.2. Calculator, do you have calculator?
Phone
Okay, yeah, 1.8 I think. So this one will be around 0.8. Okay, this should be around 0.8. So it should be, so x is equal to, here it is 0.8 into divided by 10 power 6. Okay, this one is 1 divided by 1.2, it will be approximately 0.8. So 0.8 divided by 10 power 6 meter. Now I am taking as 0.8. Yeah, I can substitute here itself 0.8. Okay, 0.8 into this divided by 6 will go upstairs, it will become minus 6. So 0.8 into minus 6. So this one is 10 power 3. This one is 10 power 3 divided by 10 power 3 divided by 10 power 3. So this 10 power minus 6 into 10 power 3, this will remain same. This will go upstairs, it will become 10 power minus 3. So 10 power minus 3, 10 power minus 3, it become 10 power minus 9. This 10 power 3 will remain constant. So it will be so this one now 0.8 into this step you understood. At least up to this you understood. 0.8 divided by 10 power 6. So 0.8 into 10 power minus 6. Then into 3 divided by 3. Okay, you needed that plus. Okay, so 10 power 3 divided by 10 power 3. So this 10 power 3 will remain same. This 10 power 3 will go upstairs, it will become 10 power minus 3. Now 10 power minus 6 plus 10 power minus 9 will constitute 10 power minus 9 into 10 power 3. So 0.8 into 10 power minus 9 into 10 power 3, now it becomes, so minus 9 you have to take outside, it will become nanometer. So this, here it is meter, here it is nanometer. Now 0.8 into 10 power 3 is, it should be 800 nanometer. So I am teaching everything now. A for apple, B for biscuit, C for cat. This calculation and all, everything I am teaching you now. This and all you have to skip. Over?
Yes,
Over?
Sir. Yes, sir. Yes, sir.
At least you understand now.
Yes, sir.
Should I repeat? No. Should I repeat?
No, sir. No, sir.
So the Bose, now comes the Bose model. So the Bose model tells that the electrons are revolving around the nucleus. So when the electrons revolves around the nucleus, Bose model tells that electrons are revolving around the nucleus. So if the electrons are revolving around the nucleus, the total angular momentum L is equal to nh by n phi, no.
2 pi r is equal to
No, nh by 2 pi. What is h here? H is the Planck's constant. N is the number of
shell orbit.
Number of orbital shell. It could be 1, 2, 3, etc. Okay, so L is equal to nh divided by 2 pi. So then total frequency, total h nu is equal to EF minus EI. That is h nu is equal to EF minus EI. EF is the final value, okay, energy transition of the final value. The E1 is the energy of the initial value. That means what is EF and EI? What is EF? Final energy and initial energy. Final energy and initial energy of the electrons that is jumping from one valence to the another valence, okay, one orbital shell to the another shell. So this is a chemistry, right? This is a chemistry, orbital shell. How many orbits are there for any element you can take?
Sir, it depends on the
Other element that is present. You know, any one element you take and tell.
Sodium 3.
No, why are you taking sodium all? Say don't take sodium. Sodium, carbon. Carbon is 1s2, 2s2, 2p. 1s2, 2s2 and 2p? 2p2. Total number is 6. So 1s2 carbon. Just go for carbon. 1s2, 2s2, 2p? 2. So how many orbital here?
2.
Two shells. And so okay. Now we come for here. For example, the electron that is the outer shell is fall into the inner shell. So what is the h nu value? Is the total energy difference? Now the energy difference is final minus initial. Okay. So final minus initial means which will be greater now? Which will be greater here? Which is final or which is initial? That itself we have to tell. Which is final or which is initial, and which will be the greater?
Electron on the higher energy shell and the lower
energy shell, where the electron in the higher energy shell will fall into the lower energy shell. Okay, so which is EF and which is EI?
Electron in the final energy.
EI வந்து இனிஷியலா இருக்கும் சார், EF வந்து ஃபைனலா இருக்கும். அப்ப வந்து இனிஷியல்
that's
அதிகமா இருக்கும்.
No, that only
greater than final energy.
Initial is
Greater than final energy.
initial is greater than final energy. Who's supporting him? Initial is greater than final one. Okay, he is telling initial is greater than final. Okay, who is supporting him? So you are supporting him.
Thank you so
Then
much.
at least you understood now. Electrons from the outer orbit falling in the thing. So what you told, E is greater than EF. EI is greater than EF. So another possibility is EF is greater than EI. So only one person is supporting him. So only one person telling that EI is greater than EF. So what happened to others now? Okay, what are you telling? Oh, EF is greater than EI. That only I am asking. Then who is supporting him? That's that only I'm telling. That's all. That's only asked.
Always enter as an answer.
Sorry. Okay. So then it should be. Then others should then EF is greater than EI. So others is telling that EF is greater than EI. Okay. So the first one is, so what is first one? The inner shell, outer shell, which is outer shell, electron present in the outer shell will fall into the inner shell. So why EI is greater, EF is greater than EI?
Electron mass like energy அதிகமா இருக்கும். Final.
Electron which is near to the nucleus will have the highest energy. Electron that is revolving towards electrons which is revolving around the near to the nucleus will have the high energy. So it should be when the electrons that is falling, when the electrons that is outer shell to the inner shell, when it's falling, if it is that's depend upon the which is the electron nucleus. That's why binding energy, what is binding energy? What is binding energy? I think I took it in the last class, no? Binding energy.
Binding proton and neutron.
It's a nucleus you take. Proton and neutron. So what is binding energy? Between proton and neutron, neutron and proton, and neutron and proton. It will have high binding energy. Okay? Which will have high binding energy? Electrons. The smallest hydrogen will have the highest binding energy. That's why they use what's the process is going on in the sun?
Nuclear fusion.
Nuclear fusion. I am fusing. This also I teach in the last class. No? Hydrogen will give. Hydrogen plus hydrogen will give deuterium. Deuterium plus hydrogen will give deuterium. What is it? So what is it? For this process has to undergo what? This hydrogen deuterium to undergo what process I have to use?
Nuclear fission.
I have to use nuclear fission reaction. Why I have to use nuclear fission reaction? Because hydrogen should combine. Hydrogen which temperature hydrogen will combine? 5000 degree, almost 6000. Okay, 5000 degree. Only at 5000 degree only hydrogen will combine. That is, this process only is going in the sun. So that means binding energy will be higher. So binding energy is higher means when the proton and that is for smallest only the thing is there. Now I am coming for here. The electron that is attached to the electron that is the inner shell orbital will have the highest energy. Outer one will have the lowest energy. So when the outer shell is fallen to the inner one, so this will have the EF will be greater than EI. Okay, so this is similar to what this one. This, if you understand this concept, you can understand this also. Okay, so it is similar trend. Now No, I will explain everything. Hey, why are you worrying it? It's not. Which one Q?
R1 இல்ல சார் அந்த
Q.
R1 equal to H2 mu not pi
இதுவா?
அது கீழ அங்க சைடுல அந்த சைடுல அது Q
இதுவா? A0, not Q கிடையாது. A0.
அதான் A0 A condition A man equal சார் அது என்ன சார் அது ஏவா யூவா சார்
இதுவா?
அங்க ME மைனஸ் ME அங்க மேல சார்
4.
4
Now total angular momentum of any total angular momentum of any electron that revolves around the nucleus. So L is equal to mvr. So mvr L you can take it as m into Vn Rn, or you can take Vn Rn or mvr itself you can take. Okay, is equal to LH by NH by 2 pi. Okay, 2 pi. So now Vn is a Vn or V is equal to, you can take V is equal to E divided by 4 pi epsilon root of root of m Rn, or you can take a V itself, don't go for Rn because it's the same notation. Rn, nothing is needed. So this one is E square V square 2 pi epsilon 0 mv mr. So, do you take this? No, you have to take this also. No, this. Okay. Okay. Now, first one is L is equal to mvr. L is equal to m. No, this. L is equal to mvr is equal to nh by 2 pi. Okay. So, V is equal to E divided by root of 4 pi epsilon 0 mr. Okay, so V square is equal to, if you take root of it, you will get V square E square divided by 4 pi epsilon mr. Okay, now if you take Vn, no, don't take as Vn. Okay, Vn, V is equal to 1 by n E square divided by 4 pi epsilon 0 1 by h by 2 pi. What is h here?
Planck's constant.
Planck's constant. H is Planck's constant. It's not actually h itself. It is different, entirely different. There is no h here. It's
H bar.
not. It's not h bar. It's h dagger. H dagger. It's not h. It's h dagger, which is Planck's constant. Okay.
Planck's constant oda symbol அப்படிதான் இருக்கும் சார்.
H dagger. H dagger. So this one is h dagger. So V is equal to V square is equal to now. Now how you got the V square here? You for V is equal to E divided by root 4 pi epsilon 0 m square.
Squaring on both sides.
If you remove this root, what will happen now? No, if you remove this, no, that I'm not asking. I am removing the root, so you'll get V square is equal to E square divided by 4 pi epsilon 0 mr. How you got V square here?
Root and squaring on both sides.
No, that's okay. How you got V square? How you got V square? What is kinetic energy? K is equal to half mv square. So of kinetic energy is equal to half mv square, So if I substitute this value here, so what I will get? Let us assume V half mv square. So if V is going, or you can take like this. So now we first I am taking V is equal to E divided by root of E0 4 pi epsilon 0 mr. Okay. So if I take I am squaring both the sides. So you will get V square is equal to E square 4 pi epsilon 0 mr. So mv. So I am taking m outside. Okay. M outside. So you will get mv square is equal to E square 4 pi epsilon r. So now we are adding half on the side, both the side. So half mv square is equal to E square divided by 4 pi epsilon 0 r. Yeah, 8 pi epsilon 0 r. So now this is the V is equal to E divided by root of 4 pi epsilon 0 mr. So V is equal to 1 by n. If I substitute this value, V is equal to here, I am substituting this value here, what will happen now? 1 by n E square 4 pi epsilon 0 1 by h by 2. That is n by 2. So I am bringing everything here. V is equal to E divided by root of 4 pi epsilon 0 mr. That value I am substituting. What is here? M V R. If I substitute this value here, what will happen? I will get the total. This one is not V, this one is R. Okay, R is equal to 1 by n E square divided by 4 pi epsilon 0 1 divided by h you can take as h dagger divided by 2 pi. So R is equal to now n square divided by m h by 2 pi divided by 4. You have to take inverse of it. Okay, yeah, inverse of it. Okay, so if you take R is equal to n square divided by m h divided by 2 pi 4 pi epsilon 0 E square. What is E square here? Mass of the electron and mass of the nucleus. Now R is equal to, so if you make all the calculation, this you have to do. Okay, you will get finally substitution everything, you will get h squared into epsilon 0 divided by pi m E square, and this one is this radius is called the Bose radius. Bose radius is given by h squared by epsilon 0 divided by pi m E square. Okay, so total energy, total value E is equal to total value is En, and total energy is equal to E square divided by 4 pi epsilon 0 m in divided by n square 2 pi whole square E square divided by 4 pi epsilon 0. So finally En is equal to minus h E4 divided by 8n square E5 E epsilon 0 square h square is equal to minus 13.6 n square EV. What is EV? EV is the electron volt. So n is what is n square?
Number of shells and the shell.
Yeah, number of orbital position. For example, n is equal to 1 means what?
K shell.
N is equal to 2 means
L.
N is equal to 3?
M.
That's all. So if I substitute this N value, I will get H minus 13.6 electron volt. What is this minus? Finally this minus. This minus tells that force of attraction electron towards the nucleus. So all the electrons will be rotating around the nucleus. So if this is negative, so the negative sign denotes that force of attraction, that is electrons and nucleus are bounded together. Okay. So what could be the radiation that I can send to remove this electron from the nucleus? What is a magnetic spectrum? What is the things I can send it here? What is the negative sign tells that? Negative sign tells negative minus 13.6 divided by n square EV. E is the electron volt. N is the number of orbits. Okay. So if you can substitute 1, 2, 3, 4. Okay. Whatever you want, you can substitute 1, 2, 3, 4, etc. So if I substitute this value, this it tells. What is my question is why it is negative? What is negative? Why it is negative? Force of? Force of attraction. Electrons is always attracted towards the nucleus. Okay. So if that is case, what is the electromagnetic spectrum that I can supply to break that energy? That is the break the electrons revolving the energy between the electron and nucleus. Any spectrum you can supply and break the energy. So you understand my question or not?
Yes, sir.
So what is the spectrum I can spend? Then
Gamma rays or UV rays.
Gamma rays. Why you have to spend gamma rays and UV rays? What is the available thing? What is available thing? What is available thing?
இதோட frequency விட யூஸ் பண்ணக்கூடிய ரேவோட frequency அதிகமா இருக்கணும் sir.
Yeah, correct. This is a frequency that is bounded should be more than the frequency of the thing. That is the theory of relativity.
E is equal to MC.
No, அது வேற. Photoelectric emission. Photoelectric emissionல என்ன சொல்லுது? The rays வந்து அதிகமா இருந்தா the kinetic energy of the electrons will be more. So that we going to see in the next chapter. So this and that one is both are connected. So if that means the electrons that is having the force of attraction towards the nucleus, if I supply the rays like solar cell or something, any rays, sunlight, any light rays, something like that, if I supply, what will happen? That will break the force of attraction between this value. That is the nucleus and electron could be broken only by the extra force like electromagnetic spectrum, like sunlight, UV light can break this force. So depend upon the attraction, depend upon the type of attraction. You taking this?
Yes sir.
N2 which one?
மேல
NH
அது இல்லங்க 2 pi r equal to
2 pi r n lambda. N lambda. So de Broglie's wavelength. De Broglie says that 2 pi r is equal to n lambda. So 2 pi r is equal to nh nh can take. Okay, nh divided by mv. Okay, h is the Planck's constant. So if I take this h is equal to Planck's constant, Rn is equal to nh divided by 2 pi mv, which is that this r is the radius you know, and this is the de Broglie's equation.